Kernel. Today I'm going to talk about kernel density estimation. Density estimation is a way of calculating the probability distribution using a given sample in non-parametric way. So what do you mean by that? So let's say we have a sample here. Let's say we have a 10 sample here, 10 samples here in this graph. And what we do is that we draw bell curve at each point, a bell curve at each point, like a Gaussian curve, like a normal distribution curve at each point. Then we'll have this, like we have these points. So these are all these what is this? Red lines. These are all points. Okay, these are all points. So we have around 10 of those here, and we draw this bell curve on each of those points. And so what we do is that at and so what we do is we take any point here. Let's say suppose we take this point. Okay. So let's say we'll take this point, and we'll take this point, and we will add the height of these curves here. Like we'll add the height, this curve. What is this here? Okay. This will had a height of the this curve. We'll add the height of the this curve. This curve, this curve, this curve, this curve. We'll add all these heights. Add height this one. Then we'll add the height of this, and this. We'll add up the height, and when you add up all the heights of these curves, then what we get is total height. What we get is the total height, and it reaches up to here, right? So this is the total height of the all these small all of these curves at a given point, and it's up to, and we draw a point here. And the same way, let's say we take this point here, right? We take this point here, and we add up the height of this one, this one, and we add up the height of all this thing, and we get up to this point, and it becomes this. So if we do this for each of the all of these points, then we get this kind of hill-shaped graph, now which we call kernel density estimation, and it provides us the probability of the getting a probability density on of the any given point within this range. It gives the probability distribution of the any point within given this range. So it says like a -2 is almost zero, right? And 6 is zero. So even though you didn't have the initial point in a sample, you can get the probability function of that particular point using this curve. So for this one, what we have is around somewhere around 0.05%. You see, 0.05%. So that's how we find the probability distribution function, distribution of a given of any point within the range, using kernel density estimation. And this is easily done by using R. And it's not hard at all. And this is a function we use in R to do the kernel density estimation. And that's what I'm going to talk about today. How to do the what is kernel density estimation, and how we're going to do that in R. But even though we didn't go into detail, but I just want to give you like a brief overview of what is kernel density estimation, and why it's useful, right? So that's all for today. Thank you. Bye.